And imagine like voltage is coming from over here and it goes down past here, and you're trying to catch it right in this window. Hey guys, welcome back. Steve here with 6 Star Automotive. Today I'm going to start a new series about lab scopes. So I've been super busy with the shop. I built a new desk. I had another partition made to separate part of our office into a shipping and receiving kind of a hub area. Really just been kind of generally reorganizing everything to work a bit more efficiently for the guys here. So that's basically what my time has been devoted to right now. So the videos have been kind of on the back burner. But I do love this topic, and it's something that I want to definitely get criticized about online. We'll see how this goes. These are the lab scopes that I have currently. I've had more over the years, but these are the ones that I still have. I got my Fluke 97 I've had since, I don't know, 2007 or so. This is kind of this was the ticket back in the day. This is the one that everybody had. So what is a scope? So they go by a couple of names. You have lab scope, digital storage oscilloscope, DSO. What they do is they measure voltage over time. So instead of like a multimeter that measures voltage on an average over time and just gives you kind of a snapshot of what's going on, a scope gives you a linear graph or a sine wave of what the voltage is over time. The difference being that with the digital storage oscilloscope, you can record a section of time and then go back and look at them and zoom in and zoom out and kind of, and you can do more with the information. Something like the uScope is, as you can see, extremely compact. It's about the size of one of those Ridge wallets, or maybe a little bit thicker, but I mean, fits in the pocket. These things are incredible. Scopes have multiple channels. So you have a scope like this, which is a single channel. So you get one signal and one ground with this guy. You can monitor one signal, and that's good for most cases. But if you do need two signals, like if you want to look at a cam and a crank, or if you want to look at like a coil primary and an injector, looking at one and then looking at the other. You need to see exactly in time when they are correlating to each other. Then you'll need something like a 2-channel scope, which is what this guy is, or a 4-channel scope, which is what this guy is. You can also go crazy into like the pico territory. Pico scopes can be in the $7,000 range. I mean, this one is, in the $10,000 range. So, but this is not just a scope. This is a scope and a scanner put together. So Snap-on also does sell graphing multimeters and scopes that don't have the capability of a scanner, and that can get you lower in the price range. But I've always kind of had these. I've had my Veris, which I liked a lot because the Veris actually has the scope module built into the scanner, so you don't have to plug it in separate like this guy on a dongle and have it in. But every scanner, scope combo, every tool you have is going to have its benefits and its downsides. So you really want to do your homework and research and figure out what would work best for you. But I can guarantee you, if you're just getting started, this guy right here, bang for buck, is going to be probably the best route, because you're going to get what you need without going crazy breaking the bank. You're probably $400 with this guy. AES Wave is the place to go for this kind of stuff. They sell the uScope and they sell lead kits. I'll show you a lead kit that I actually just got recently. This thing is awesome. Super sexy packaging from AES Wave. Let's see what we got here. So this test lead set is so cool. It's only like $260, and you get all of these little individualized leads. So you have males and female versions of 2.5 millimeter, 3 millimeter. You got males, female. I mean, this stuff is, you got the circular kind, the males and the females. You have so many you can pin into. You can actually front probe rather than always having to back probe with T-pins. So these things are a really cool addition. You've got all kinds of stuff in here, from amp loops. So you plug this into your fuse, you put the fuse in here, you can see if you've got power on this little LED, you can hook up an amp clamp. We can go over that kind of more advanced stuff later. But anyway, just know that AES Wave has some really really awesome stuff on their website, and the quality is fantastic. So if you don't know about AES Wave, go to AES Wave. Check out their website, nerd out for a little bit, and buy some stuff, because those guys are phenomenal. I've been buying stuff from them for 15 years. Alrighty, so let's get into some basics. So I have this really cool tool here called an Automotive Signal Demonstration Board. It came with this guy, and I'm gonna hook up my scopes here, and I'm gonna show you how this little sweet machine works. Let's take a look. All right, just like anything, it's gonna need some manner of power source. In this case, we're using a 9-volt battery. So you can see with this, I don't know where you're gonna be able to find one of these if you did want one, but it's called an Automotive Demo Board. If you can see that. And your test points are these guys right here. And I'll show you how this works. So with any lab scope, we'll go with this guy right now. Turn it on, obviously. We've got a little power going on this side. This one is charged. It doesn't have batteries inside. It's got a USB, like micro old school USB. So you'll need to have that charger. I don't know if the newer ones, that'd be kind of cool if they had USB-C. I'm not actually certain if they do or not. So we can go up and down on the scope. We're gonna go on this case to lab scope. It has a couple of pre-set settings. So I always just go straight to lab scope. That brings you a live feed of what's going on. So these are what are called divisions. So you see these squares. Every square is what's called the division. This isn't touch screens. You have volts per division. So if you're looking at the bottom, this is our voltage scale. So if you look here, we have 1 volt. That means per division. Now we have 2 volts per division, 5 volts per division, 10 volts per division. And then you can see at the top here, this is going to show our max voltage. So now that means that from this line to the top is 64 volts. And now it's going to be 32 volts. And then 12.8 volts, and now we're zoomed in at 6 point some volts at the 1 volt per division. So that means that every one of these squares represents 1 volt. And then the other scale over, if we go over, right, now we're here, is going to be our time. So now we have 5 milliseconds. So we can go up to 10 milliseconds, 20 I believe is what that, I can't read it. 20 milliseconds, maybe 50, there's 50 milliseconds, 100 milliseconds. And you can see how the green bar is going slower across the screen as we go. So it's going to take that amount of time, in this case 500 milliseconds or half a second, to get across every division. And I can go even slower. So now it's 1001, 1002, 1003, 1004. You see how it's taken 1 second to get across every one of those squares. And that's how you figure out where you're going to be in that specific signal that you need, is really just going to be those two. So here, and this is the trigger. So the trigger is this yellow line. So you can change your trigger, and like in this case, we can move the trigger down and we can move the trigger up. So if you don't want that signal to show up on the scope until a certain time, that'll help you kind of keep it in this window. Because you gotta imagine, like, voltage is coming from over here and it goes down past here, and you're trying to catch it right in this window, in that time scale. So, if you're looking for like a spike, and it's an intermittent spike in voltage, like a ignition waveform or something like that, which I'll show you in just a second. Sorry, the red is gonna be your up slope, and then you've got your down slope. And then that tells you, like, if you want to catch it when the signal is going up, or do you want to catch it when the signal is going back down. And then your next item is going to be inversion. So the next one we're going to go to is here. So you can see now we have inversion, and you're either going to be inverted or you're going to be not inverted. This helps when you have negatives, like if you have your leads backwards and you don't necessarily want to disconnect everything and put your leads back on, you just invert the signal. So instead of the signal being down here, it flips the signal upside down and puts it up here. So that's, sometimes I'll show you that as well. And then we've got the last option is the menu, and then you can go nuts in this menu. These two are the guys you're going to play with most, or your voltage scale and your time scale. So those two are the ones you really need to understand. So let's hook this guy up and see what we've got. So now I can take my good old snappy and I can connect them to here. We've got our positive, we've got our negative, and this is a secondary negative for multiple channels, so you don't have to run negatives all over the place. You just stack them together like this. See what I mean? So this is super cool. But anyway, it helps you with more advanced stuff. In this case, this negative's not necessary. So now we have our scope, and now we have our short leads, and we have our positive and our negative. So we have 5 specific signals. So you see number 1 says injection, number 2 says secondary ignition, number 3 sweep, number 4 gen sensor, I don't know, we'll see how that goes, and then oxygen sensor is number 5. Anyway, let's take a look at this and we'll see what it does. So this is the signal that it's producing right now. That's what this little machine right here is producing, this signal. So what is happening is that my time scale is so far off that it's actually having a hard time grabbing the signal. So what we're going to do is we're going to move it over to our time scale. See the second one here? And we're going to go down. Keep going down. Now we have 200 millis. Now see how it's starting to show up easier? We go down more, 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 more. There we go. See, now what you can see what happened is we're zooming in to one of these individual signals. I mean, the signal is all still there. It's just stretched out this way and it's stretched out that way. But we are using it to zoom back out and see all of them. See, but it's a lot for this thing to compute all that stuff. I mean, it just ends up being a big giant bar. So give it a second to compute. There you go. See all that? Too much. We don't need to see all that. We just need to see, we need to get closer, and we're going to zoom in further. So now we're at 20 milliseconds. Now we're at 10 milliseconds. And now we can see, but see how it's still kind of too big. I mean, it kind of works, but let's go back over. We'll bring this guy. There we go. Okay. So see what you got to do? You kind of got to fidget with the thing in order to get the signal where it fits inside of the screen well. So in this case, we've got it at the 5 volts per division, we have 10 milliseconds, and we've got it on normal. Our trigger is also kind of down here. The voltage coming in this direction, it drops down to ground, and then it spikes back up when it shuts off with that inductive kick, and then it goes back down to regular voltage. So what we can do on the machine is we can change this, and we're changing the pulse width. You see that? And that's how the injector changes the amount of fuel that it injects. So I'm actually just moving this dial right here. I can swivel the dial, watch my fingers, won't, see here? And I can increase and decrease the injector pulse width. So let's check out another signal really quick and we'll get an idea of what we're looking at. So next signal is secondary ignition. So we're going to go to 2, and then we're going to look here. So now you can see what's going on with this signal is that we can't exactly see it again, right? We're out of the range of being able to see this signal properly. So let's go over to our volts, and we're going to back off. Here we go. There we go. Alrighty. So you see how as we zoom out and zoom in, we can change how close we can see. So you can actually see the yellow line, the trigger is just above. So I'm going to try something really quick. I'm going to try and invert this signal and see what it does. There we go, look at that. So see, that's where that inversion comes in, is that you can flip the signal upside down on itself. And then that can allow you to get into a better view of what you want to see. In this case, it might not be the best idea, but let's keep playing with it and see what we can come up with. We're going to go back to our time scale. We're going to see this is not helping. And this is a good thing to know. So you see how the voltage lines are not going up as high with some of them, but they are with others. So this is data loss. What's happening is that it's trying to capture all this information, but it doesn't have the ability to catch it and project it as fast as it's seeing it. So it loses some of the clarity in the image when it's just like a pixelated image, I guess is the best way to look at it. So if we bring this guy back, see, the closer we get into the individual image, the more consistent it becomes, because now it doesn't have to show all that junk on one screen and start losing resolution. That's the best word. It loses its resolution as you bring it out and try to put more junk on the screen. So we're going to keep it in nice and tight, and we're going to look at one of them. It's a digital representation of what a secondary ignition signal kind of looks like. So this is not exactly what a secondary, that's why it's throwing me off. So let's look at that next signal. Our next signal is going to be a sweep. So that's why this is so important. So let's go over. Here we go. We're going to change this guy to auto again. And see I'm going to move this sweep, and you're going to see this totally drastic, unmeasurable amount of change. See, that's the issue, is that now we're looking so fast, we're not going to be able to see what's going on. So I'm going to change this over, and it's so difficult to do this upside down and backwards. I'm going to change the inversion, and I'm going to move it back to a higher voltage. So see how a slower time scale. So now we're looking at 1 second per division. So we're way slower than we were before. And then we're at 0.2 volts. We're going to look at a TPS, or a throttle position sensor sweep. And this is usually what you're going to be looking at. But we need to increase our volts per division to 1 volt per division. Let's do it. There we go. So we've peaked out right there. And we go back. So this is exactly what we want to see. So I'm moving just like you would if you were hitting the throttle, right? You're going to hit the throttle down, you're going to hit the throttle back up, and you can see that we're looking right at the line. And what you're looking at when you do these sweep tests is for any kind of like bang, kind of weird jumps where it goes all the way to the ground or goes all the way to 5 volts, without a nice, smooth, gradual change. What's our next one? Next one is a gen sensor. So let's see what this guy does. So now look at this. So you can see another reason why we need to make sure that we understand how to use this guy, because now we have so much junk going on that we can't see anything. One of the most important things to understand with a scope is that you need to know what you're supposed to be seeing. If you're just looking at this going, yep, that's a signal, what are you going to do with that? You need to know what you should see so you know if it's wrong. So we're going to bring this guy back, going to go to our milliseconds, and we're going to speed up. So we're 10 milliseconds, 5 milliseconds per division, 2 milliseconds, 1 millisecond. Now look at that. Okay, now we have, it looks like a pulse width modulated, like a Hall effect type signal. So we have a square wave. So we're going up to, let's see, we're at 4.99, so it looks like a 5 volt square wave. So we have 1 volt per division. We can see the entire signal, so that's fantastic. We don't have to necessarily move, and we will, so let's take a look. We'll scooch over to our volts per division, and we'll change that guy. So if we go up, see it shrinks down our scale, and it gets to the point where see how when it goes below the trigger, the signal will just kind of bounce around through the screen. It doesn't really stay still. But if you can get your signal into the trigger, bang, see how it stays still? Now it'll lock it into the position when it hits that trigger point. Otherwise, it'll be below it or above it. So now what I can do is I'm going to change this signal, RPM, there we go. Okay, so what this is it says general sensor, but I think what this actually is a, it's like a crankshaft position sensor. Scanner Danner's book, man, you really should take a look at his book. I forget the name of it, but it's at AES Wave as well. You should buy his book. It's only like $100. I mean, you can't beat any amount of knowledge for $100. And that book will teach you so much stuff. Holy cow. But this would be like a 3-wire sensor, right? You have power, ground, signal, digital sensor. In this case, we're going to change the RPM, and it's going to change the pulse width, right, or the width of the signal. You're going to go faster. Anyway, so this is the kind of stuff you can do with a scope that you cannot do this with a multimeter. Reason being that the multimeter is looking at the maximum and minimum signals, and it's averaging them out. So like in this case where we're going from 0 volts to 5 volts, you can see here our min max, it shows you up here. So we have our minimum of 0.13 and our maximum of 5.02. Yeah, so what it's going to show on a multimeter, if you put this signal in the multimeter, it's going to show half, right? It's going to show 2.5 volts because it's just averaging all this junk out. You need to see this, because if you have any problem with that sensor and this signal is going all over the place, a multimeter is not going to catch that, but this guy will, and you'll be, oh, I think I might have a bent tooth. You know what I mean? So that's the kind of stuff that you'll be able to diagnose with this that you will not be able to diagnose with a multimeter. Last signal is an oxygen sensor, and these guys are pretty cool. I don't know, let's see what I've got to do to set this up. Generally an oxygen sensor is going to be like a 1 volt change. So let's see what this is. So you're looking at a maximum of 1 volt between this whole thing. So we don't want 1 volt per division, we want to have 1 volt for the whole screen. So let's go here, we're going to bring this down to like 0.2 volts. Okay, so see we're getting somewhere, so it's changing. And now we're going to bring our time scale up because it's a relatively slow signal. There we go, 100 milliseconds. Yeah, so let's do this even slower. There we go. So oxygen sensor is going to go rich, lean. And then we're going to go rich, Let's go a little bit slower. Lean. Rich. Lean. Rich. Lean. Very good. Okay, so we're looking at 0.2 volts per division and 1 second per division. So you can see every one of these signals that we're looking at has a relatively wide and a different range of where you're going to need to be in order to catch it. So understand what signal you should be seeing when you're scoping stuff out, so that you're not all over the place. I mean, maybe your signal's way up here or way down here, or happening so fast you're not able to catch it. You want to know what signal you should be looking at before you even grab this. I mean, without one of these, you're not fixing cars. You're guessing, and guessers are not winners. So we need to make sure that we're not guessing when it comes to this stuff. Yeah, man, if you guys have any questions, if you want me to go into a bit more detail with the multi-channel, maybe I'll do that in the next video. If you have any questions, let me know. All right, guys, thanks for watching. So I should have a fair amount of links in the description below to bring you to AES Wave and some of the stuff that you've seen here to give you an idea. But really, just play around on that website. It's a fantastic website. You can even call those guys, and they're really good at kind of pointing you in the direction that you need to go. If you guys have any questions, leave them in the comments. If you have any critiques, keep them to yourself. And I'll catch you on the next one.